The quiet problem of heat. By 2350, everyone thought heat was a solved problem. Not in the dramatic sense. Nobody expected radiators to explode or reactors to melt through hulls anymore. It was more that heat had become boring. Engineers spoke of it the way plumbers spoke of pressure. Something to root, bleed, buffer, and forget. Which was exactly why Dr. Lena Okoye loved it. She sat cross-legged in the maintenance ring of orbital platform Kestrel, staring at a wall of matte black panels that looked deeply unimpressive for something keeping 6,000 people alive. Each panel was warm to the touch. Not hot. Warm in the way a sunlit stone is warm. Honest heat. Still staring at it like it might confess, said Mark Feld, floating in upside down with a tablet hooked to his sleeve. It will, Lena said. Heat always does. You just have to wait long enough. The problem was simple to state and annoyingly hard to solve. Earth-based power systems could dump waste heat into air and water. Space-based systems could not. Every watt of power used inside a habitat or ship eventually became heat that had to go somewhere. Radiators scaled poorly. The bigger the station, the more surface area you needed, which meant more mass, more vulnerability, and more micrometeoroid punctures than anyone liked to admit on camera. By the 2330s, the issue was no longer keeping systems from overheating. It was keeping them from being absurdly fragile. Kestrel was an experiment. Not a new technology, but a new configuration. Instead of long radiator wings, it used dense heat sinks built from phase change composites. The idea was to store heat during peak activity and bleed it away slowly when loads dropped. It worked beautifully on paper. In reality, paper did not expand microscopically, fatigue unevenly, or develop personality quirks after a few million cycles. Lena tapped the panel gently with her knuckles. You feel that? Mark pressed his gloved palm beside hers. Feels like every other panel. Exactly, Lena said, smiling. It should not. She pulled up a graph and rotated it so he could see. A slow oscillation. Almost rhythmic. The composite lattice is self-organizing under stress, she said. Not breaking. Adapting. Mark frowned. Materials are not supposed to do that. Neither were reusable rockets, remember, Lena said. Until they did. The breakthrough was not a miracle material. It was a compromise. The lattice structure inside the heat sinks was allowed to deform slightly over time, redistributing thermal stress instead of resisting it. The station would slowly change shape at a microscopic level, like a living thing growing calluses. The trade-off was longevity. These sinks would not last forever. They would age. They would need replacement in decades, not centuries. Which was fine. Because the alternative was pretending perfection was possible. When Kestrel ramped up to full industrial output for the first time, Lena stood in the observation blister with a cup of recycled coffee and watched the numbers climb. Heat flowed. Stress redistributed. Nothing screamed. She raised the cup in a small salute to the unglamorous victory. Out beyond the hull, the panels glowed faintly in infrared, quietly telling the universe that humans were still bad at dealing with consequences, but getting better at listening to them.